your time is different from my time. Your 1 second could be my 2 seconds. And I'm going to prove that in this video. Hey guys, welcome back to another video. In this video, I'm going to show you guys what time dilation is and how your time is different from my time. So if you haven't watched the first video of the series where I explain what the two rules of relativity are and what a space-time diagram is, make sure you watch that first, because in this video I'm going to be using those two rules and what a space-time diagram to show you what time dilation is and how your time is different from my time. Special relativity is all about understanding how motion looks from different perspectives. Let's start with using the two rules of relativity and our knowledge about space-time diagrams to figure out how the same event looks from two different perspectives. And to do that, let's set up an event. Person A is standing on a sidewalk and he sees a bus move across the street at a constant velocity. We'll call this A's frame of reference or A's perspective. Now, inside the bus there is a person B with a laser in his hands. As the bus moves across the street, he shines the laser that hits the mirror at the front of the bus and returns back to him. We'll call this event where he shines the laser event 1. The event where the light beam hits the mirror, we'll call it event 2. And the event where the light beam returns, we call it event 3. Now, let's project this set of events on a space-time diagram. Here's a space-time grid. For this grid, we've chosen the scale of the x-axis very cleverly. Every tick to the right is 300 million meters. This is done because light moves at 300 million meters every second. So the world line for light will be at a 45-degree angle. One more thing to notice is that moving down the y-axis means moving into the past. So here are the events that we need to plot on the space-time diagram. Let's plot event 1 at t equals minus c. Next, we draw a line at 45-degree angle to represent the light traveling towards the mirror. The light reaches the mirror at t equals 0, and so that is event 2. Now the light is reflected back and reaches person B at t equals plus c. This is the space-time diagram for events as seen by person B. Let me repeat, this is how B sees the three events. Our aim is to figure out how person A sees the same three events. So we want to plot the space-time diagram of B onto the space-time diagram of A. Essentially, we want to take the time axis and the x-axis on B's space-time diagram and draw it on A's space-time diagram. So, let's start with the time axis. And to do that, first, we need to notice that any stationary object in B's space-time diagram will have a vertical world line. But for A, the same line will be slanted, because for A, the object is moving with the bus. Therefore, the time axis, which is exactly like this world line, will be slanted in A's space-time diagram. How slanted? That depends on how fast the bus is moving. Here, we use the second rule of relativity that the speed of light is the same for all observers. Therefore, we start the world line for light at t equals minus c and draw a 45-degree line again. But notice that this time, the 45 degree is relative to A's space-time diagram, not B. Now that we know event 1 and event 3, to find out where event 2 is, we need to extend this line. Then draw another line at minus 45-degree angle from event 3. Where the lines coincide, that is where A sees the event 2 take place. And if we connect event 2 to the origin, you get B's x-axis onto A's space-time diagram. Let's read the diagram. What happened at t equals 0 in B's perspective clearly didn't happen at t equals 0 in A's perspective, which means that the same event happened at different times for different observers. This is just not it. This result breaks our intuition about simultaneous events. Events are simultaneous when they happen at the same time. If two events do happen at the same time for person B, they don't happen at the same time for person A. And so, they're not simultaneous for all observers. And this is what time dilation is. So if you learned something new from this video, make sure you like it. And if you want more such videos, make sure you subscribe to the channel. And I'll see you next time.